This video is an overview of lesson 6.3, which is all about sampling distributions and estimators. These slides are based on slides provided by Pearson to accompany our textbook and then modified by me for our course. So this is the third section of the 4 sections that we're covering in chapter 6 of Essentials of Statistics, 6th edition by Mario Triola. Chapter 6 is about normal probability distributions. In 6.1, we introduced the idea of a continuous probability distribution, and then we talked specifically about normal probability distributions and the standard normal distribution. In 6.1, we found a correlation between areas under a curve and the corresponding z-scores. Then in 6.2, we said, well, what if that normal distribution is not a standard normal distribution? So what if the mean is not 0 or the standard deviation is not equal to 1? Because most normal distributions are not standard normal distributions. Well, it turned out there was a very nice correspondence that would allow us to take a non-standard normal distribution and convert it to a standard normal distribution. And then we were able to do with non-standard normal distributions everything that we did with standard normal distributions in lesson 6.1. 6.3 is a little different. We are no longer focusing on the data itself, like the data in the original population, but we're going to focus on the distribution of different sample statistics. Now, I know that sounds a little strange and a little different. It's a little bit meta. So this is kind of a meta lecture. Here you're going to see how all of these ideas that we've been learning get richer when we look at them on a slightly different level. So we'll do that in 6.3 with sampling distributions and estimators. And then in 6.4, we'll talk about the central limit theorem. So the key concepts of this lesson are that we want you to understand, or I want you to understand, what a sampling distribution of a statistics actually is. And then I want you to know how you can summarize that sampling distribution with a probability distribution and what that sampling distribution can tell you about the corresponding population parameter. Now remember, statistics go with samples, parameters go with the population. So if we have samples from a certain population and we calculate the mean, what we're calculating is that X bar, the sample mean. Well, the distribution of all of the different X bars can tell you something about the population mean. So that's what I mean when I'm talking about this bit right here, when it says, I want you to understand what that sampling distribution of that statistic, which is something calculated from a sample, can tell you about the population parameter. So again, as I was saying before, rather than working with values from the original population in lesson 6.3, we're going to focus on statistics obtained from that population. So sample proportions, sample means, sample standard deviations, and then what those can tell us about the population. So here are our learning outcomes. First, we're going to describe the characteristics of a sampling distribution of a statistic. Then we're going to describe the specific sampling distribution associated with sample proportions and that relation between sampling distributions of sample proportions to the population proportion. And we'll do the same thing with sample means and the same thing with sample variance. And then lastly, we'll discuss the difference between biased and unbiased estimators, and we'll list 3 examples of each. So we'll see that we are familiar with a lot of estimators, and I'll define that for you again later. But there are some of them that are known to be biased and some of them that are known to be unbiased. So we're going to talk about which ones are biased and which ones are unbiased and what that means for us. So that is what we'll be studying in 6.3. I will see you in the first video or the next video to discuss learning outcome number 1.